Okay, 7th grade, welcome back. The section we're going to talk about today is going to be section 1.8, properties. Okay, what I want you to start off with, I'm going to give you this quick warm up. We have Riverside Museum. Admission to the Riverside Museum is going to be $12, and an IMAX movie is going to be $8. Your task is right now to find the total cost of admission and a movie ticket for a 4-person family. Okay, so for 4-person family. Go ahead and pause the video and do that now. Okay, let's talk about a little bit how to do this. Okay, so if you notice up here, we have admission is $12 and there's a 4-person family. So every person in the family needs to get into the movie. They need to pay $12. Okay. Now, secondly, every person in the family needs to pay $8 to get into the IMAX video. So if you did for like that, ladies and gentlemen, you are correct. Great job. Now let's talk a little bit about the significance of how this works and whatnot. So if we go ahead right here and we add these two together, 4 times 12 is 48. And we go ahead and do 4 times 8 is 32. 8 plus 2 is 10. 4 plus 3 is 7, plus our 1 is 8. Ladies and gentlemen, it's going to cost them $80 altogether. Now I've got a question for you. While we're talking about, or since we're introducing into our properties, could I go ahead and write it like this? I'll change my color here. Could I write it like this? Could I go 4, 12 plus 8? I want you to go ahead and work that out right now and tell me if that's correct or not. Pause the video. Okay, let's figure out if this is correct or not. We have 12 plus 8. 12 plus 8, ladies and gentlemen, is, you're correct, 20. And we go ahead and bring our 4 down. That should be an arrow. Okay. 4 times 20 is 80. So yes, they do check. So ladies and gentlemen, what you have just done is called the distributive property. The distributive property, ladies and gentlemen, basically means that you're either going to distribute this number all the way through 12. Let me zoom out here just a little bit. That you're going to go ahead and distribute this number like we did up here, 4 times 12 plus 4 times 8. Or we can go ahead and keep it right here. We can add these two together, and we don't do the distributive property. Basically, what the distributive property means is that you are carrying this 4 all the way through, or you're going to go ahead and add the same in here and then carry the 4. Now, as we saw, it ends up being the exact same answer, so it does not matter. So the actual wording for the distributive property, let me go ahead and write the example down here really quick. The example is going to be A, B plus C equals A times B plus A times C. Now what we got going on here is the same exact situation as we do up here. We have our we have our B plus our C multiplied by our A, or we can go ahead, in fact, and multiply our A times our B as well as our A times our C and get the exact same answer. And we know what happens because we had it right up here. We had it right up here in our 80 plus 80, and we went ahead and multiplied these out, distributed them out. Okay, continuing with this idea of the distributive property, I'm going to write some examples down, and I want you to talk through yourself and tell me if it's a distributive property or not. Okay, what I have going on right here now, I have a few examples, and we're going to go ahead and talk through them and see which ones are the distributive property. Notice right here I have 5 times 3 plus 2, and it's the same as 5 times 3 plus 5 times 2. Let's go ahead and work that out. Three times 2 is 5. 3 plus 2 is 5. 5 times 5 equals 25. Now move over here. Right here we have 5 times 3 is 15. And we have 5 times 2 is 10. Well, ladies and gentlemen, 15 plus 10 is equal to 25. Are these the same number? By golly, yes they are. So in this case, ladies and gentlemen, this first answer is yes. I didn't mean to do that. The first answer is a yes. It is. Checks marks. Now zooming down into here, I have 9 times 2. Well, 9 times 2 is 9 plus 9, or 9 times 2 is 18. And over here I have 3 times 9, 27. 27 plus 18 is 46. Come over here. We have 2 plus 3 equals 5. 9 times 5 is 45. Mr. Fike has a little bit of a goofy back here. This is not 46. This should be 45. Sorry about that, class. Ladies and gentlemen, these two are exactly the same, so we have the distributive property going on here. I'm going to zoom back out, move this back over, and by golly, we're going to go ahead and check mark that. That is correct. Now we have this down here at the bottom one. We have 10 times 3, which is 30, plus 10 times 3, which is 30, and together that makes, good job, it's 60. Over here we have 10 times 3 plus, we have 3 plus 4, which is 7, and we have 10. Is this the distributive property? We can see right now that these two numbers are different. So this is 70, so this is not the distributive property. Even though we distributed things out accordingly right here like this, it is not the distributive property because we did not get the correct answer. Okay, ladies and gentlemen, moving on into our properties, we have what's called a commutative property. If you think about it, every day you commute to school. You hop on the bus at Cedar and you drive to Spalding. And then you go ahead and at the end of the day, you hop on the bus at Spalding and drive back to Cedar. And for the Spalding students, you're going to do that next year, the year after that. So what's going on right here is basically it doesn't matter which way you write the expression, the answer is going to still be the same. And this only happens in addition as well as multiplication. Okay? Addition and multiplication. I'm going to go ahead and put a little asterisk up here for the plus sign as well as the multiplying sign. All right, it's only going to happen in addition and multiplication. So what's going on right here is basically, I'll go ahead and write this right here. 5 plus 4 is going to equal the same as 4 plus 5. Okay? Both of it's going to equal 9. Okay? It's both equal to 9. Now if I go ahead and do the same thing and I go ahead and write this all the way down here and say I put 5 in for A as well, and 5 times 4, is that going to be the same thing as 4 times 5? Well, ladies and gentlemen, yes it is, because 5 times 4 is 20. I'll do a different color here, is 20, and 4 times 5 is 20. So that's exactly the same, and it's going to equal 20. Okay, so that's a commutative property. Okay, I've went ahead and written a couple of examples down here. We're going to go through together. So remember, this is either a commutative property only happens with addition or multiplication, not division or subtraction. Okay, so remember that. So I have a couple examples down here. I want you to go ahead and pause the video and take about 2 minutes or 30 seconds or however you need to answer these questions. I need you to tell me if it is commutative. Yes, put a check mark by it if it is equals yes, or X if it equals No. Go ahead and pause the video now. Okay, ladies and gentlemen, going through this first one right here, we have 5 times 9. Is that the same as 9 times 5? Well, 9 times 5 is 45, and 5 times 9 is 45, so yeah, it is. This is an example of the commutative property. Nice job. The next one I have is 6 minus 3 and 3 minus 6. Well, 6 minus 3, ladies and gentlemen, that equals 3. And then 3 minus 6 actually equals negative 3. So is this a commutative property? No, it's not. This is not an example of a commutative property. It does not equal the same exact answer. It does not. Okay? Then moving on down here to the bottom part, we have 7 plus 3 and 3 plus 7. 7 plus 3, ladies and gentlemen, is 7, 8, 9, 10. And 3 plus 7 is 7, 8, 9, 10. Ladies and gentlemen, that is an example of a commutative property. Nice job. The next property I want to talk about is called the associative property. Okay, the associative property. If you think about it, ladies and gentlemen, the first word associate means that you associate with people or with things. You kind of can relate to them, or you can kind of talk to them a little bit. And sometimes you meet them somewhere, and sometimes you meet them another or somewhere else, but they're the exact same. So what I'm getting at here, it's kind of vague. Let me put a color on. But what I'm getting at here is that the associative property is like this. A plus B plus C is going to equal the same as A plus B plus C, like this. So it doesn't matter where I put the parentheses, the answer is going to be the exact same. Okay? Let me go ahead and write it out again. This is also an addition or multiplication. I'll put this little excerpt up there. So I can go ahead and write it like this. A times B times C equals the same as A times B times C, and put in our parentheses like such. Okay, let's go ahead and put a few examples in. Let me change my color back to the yellow. And I'm going to go ahead and move it down here. Okay, so if I put 7 plus 5 plus 3, is that the same as 7 plus 5 plus 3? Well, according to the rule it should be, but let's go ahead and work it out. 5 plus 3 is what? 8. 7 plus 8 is what? Good job, 15. Now coming back over here to this right here, we have 7 plus 5 equals what? 12. And 12 plus 3 equals what? Well, ladies and gentlemen, this is correct. It does not matter in this situation which way that you add first, you're going to get the exact same answer. This is a good example of the associative property. Okay? Let me zoom it out just a little bit more. I'm going to go ahead, change my color, and I'm going to bring this down here, multiplication. So if I do a multiplication problem such as 5 times 2 times 3, like this, is that going to equal the same as 5 times 2 times 3? Well, let's think about this here for a second. We have 2 times 3 is what? Good job, it's 6. 2 times 3 is 6. 5, bring down my 5. 5 times 6 equals, good job, it's 30. Now if I'm moving over here, I have 5 times 2 is what? 10. 10 times 3 equals what? 30. Good job. So ladies and gentlemen, this is an example of a associative property. It doesn't matter in which way you associate the numbers. Okay? The answer is still going to come out the same. Okay, class, I've written a few examples out here for you to go ahead and try. I want you to try these on your own. I'm not going to work through them. I'm just going to say, yes, it is an example, or no, it's not. But I would like you to work through them and actually show your work right here. Show your work what it means right here, as well as what it means right here as well. Go ahead and pause the video now. Okay, looking through, on this first one here, we have 6 plus 7 plus 9. Is that equal as 6 plus 7 plus 9? Well, ladies and gentlemen, this is an example of the associative property because it does not matter how you go ahead and work these two out, okay? The next example I have for you is 6 minus 7 plus 9. Is that the same as 6 minus 7 plus 9? Ladies and gentlemen, this is not the same because, as I told you, right up here it is only an addition and multiplication. I about slipped up there. Only an addition and multiplication. So there's a subtraction sign here. So this is not an example. Okay. In the bottom I have 7 times 2 plus 6. Is that the same as 7 times 2? 7 times 2 times 6. Is that the same as 7 times 2 times 6? Well, it is. We just reordered it. And multiplication, it is exactly the same. Okay, ladies and gentlemen, the final property we're going to talk about is called the identity property. Really, all that this means is in addition, it's going to mean that the number plus 0 is going to equal the number, okay? So it's the identity. So, for example, if I put in 5 plus 0, it's going to equal 5. This is what's called the identity property, okay? It's going to come out to be the exact same right here, 5, okay? You can also do this with multiplication. But instead of 0, we have to use 1. So say I use a times 1, ladies and gentlemen, that is going to equal a. And I'm using a variable here, which we know a variable is just an unknown, and I'm not really trying to be specific here. I'm just trying to go ahead and write a variable and something unknown that can, a rule that could, kind of be involved for everything. So if I go ahead and put in a number here, say I go ahead and put in 5 one more time. 5 times 1, well, ladies and gentlemen, that's pretty hard problem. It's going to go ahead and equal 5. I could do the same exact thing as 5 times, not 5, excuse me. Let me erase that. I'm going to put in 109 times 1. Ladies and gentlemen, that still equals 109, and that is going to be the identity property. Okay, so all of these will check for the identity property. I feel like the identity property is pretty easy to understand. I won't go into much depth and detail with that. Really, if you are using the addition, it's anything plus 0, or if you're using multiplication, it's anything times 1. Okay? Now, a couple of things I want to talk to you before I turn you loose on your assignment. I want to talk to you about the directions. It's very important that you read the directions. They are there for a reason, okay? And they're going to help you answer the question. So on the first page, I can see use the distributive property to rewrite each expression. So if you have, for example, I'll go ahead and do the first one for you, or with you. If you have 7 multiplied by 4 plus 3, how would you rewrite this using the distributive property? Well, you would write it just like this, 7 times 4 plus 7 times 3. And I do believe it says to go ahead and solve it. Ladies and gentlemen, the answer to that is going to be 49. Okay, I'm going to move up just a little bit more. Also, if you have it the other way, if you have what's called 3 times 9 like this, plus 3 times 6, and yes, this is an example. It's example number 3. It says to go ahead and rewrite it. So you'll rewrite it as 3, 9 plus 6. Make sure, and then you'll go ahead and answer, and I'll have you come up with the answer to that one. Make sure, ladies and gentlemen, please, please, please read the directions, okay? There's a lot going on in this section, and you need to make sure you know what you're trying to ask. It'll tell you the properties that you need to use, and it might also have you name the properties, okay? Okay, ladies and gentlemen, your assignment is going to be 1 through 48. Now, we've did a couple of them already. I've kind of picked them out of the book, and we've done them, but I want you to go ahead and redo it. A couple of things I want you to be very wary about is number 13 through 22. It says use mentally or mental math to do this. I want you to write out your steps, if you would. So, for example, if you have, say, 13, it says 8 plus 27 plus 52. I want you to go ahead and tell me what 27 plus 8 is, and then bring down your 52, and then I want you to go ahead and add these two together, okay? X and X. Add those two together. That's how I want you to do that. If it's not completely like that, that's okay, but I want to make sure you have your work down. Looks like 17 and 20, and after that, get kind of rough. Also on 23 through 24, It says 27 million as well as 108 seconds. Go ahead and split those up. It's going to be kind of confusing, but you can split those up to use a distributive property. You don't have to use 27 million. That wouldn't be distributive. You'd want to go ahead and split them up into something a little bit easier. That one there might be a little bit vague. Okay, ladies and gentlemen, I am here to help you left and right, up and down. Please ask questions. But until then, we will see you later. Goodbye.